Hello, good evening.
Hi, good evening, sir.
Good evening. I don't see any attendance yet.
Yes, sir. One was there.
Okay,
I believe he or she dropped off. We can
okay,
wait for a couple of minutes. They'll be joining in shortly.
sure. I'll do that. I think the learners they have started. Learners, I'm just waiting for the other people, and then probably we can get started. Hello, Subramania. Many of you were just waiting. Okay, one more participant has joined. Joined. So, Sachin and Subramania, do you have a in your oriented just? Otherwise, what will happen is that if we start late, uh, we might not be able to cover all the things that we are supposed to cover. Maybe just a few minutes more. I don't need to pull in the class. So in the meantime, what I'll do is I'll project my screen with you guys. And I hope that you have received all these slides, right? The slides have been shared with the NM folks. So I hope that you have received all the slides. So whatever I'm going to cover, everything has been shared for your convenience. Okay. Last piece that we were doing were to do with this data cleaning. In the meantime, Subramania and Sachin, if you have any questions, you probably can post that on the chat. And all the other people, they're coming and joining. We will we can probably discuss those questions, right? If you have any specific questions, it's a good time to ask. And what I'll do is that I'll upload this when I'll try to answer those questions. Any pertaining to whatever we have covered in the last class? Any questions? Any questions with regard to what we have covered in the last thing? Any questions that you are having? But next week, yeah, we probably will be discussing that. Rick, no questions so far, nothing from side. Fair enough. In that case, let's get started. I don't think we need to wait further. Let's get started if other people are joining. By the way, did you have any quiz in the evening? Was there any quiz which was happening during the evening? Just trying to gauge that are people did it from that. Okay. So then I think that some more people might join subsequently. Nevertheless, let's get started with our regular schedule, right? So here is what we are supposed to do: data pre-processing and classification, right? That is what is my agenda for this session. And once again, like your other sessions, right? Here are the acknowledgement and the disclaimers, right? The books that you see out here, those are probably the master books which are there. For example, this book, Hand and Camber, Data Mining Concepts and Techniques. This book I have also used, right? Like the first or the second version when I was a student, right? Yeah, this book is still so relevant even today. They have obviously changed the versions, they have updated that. And then this other book which is there, these Laros and Laros, that's also a wonderful piece of book, right? It was earlier not available in India, but thankfully, once again, we're getting the reprints in India. A wonderful book. Have a look. And the third one, Professor Dinesh Kumar, Business Analytics, Science of Data-Driven Decision. Some of the parts are even taken from that. Dinesh Kumar, a professor in IIM Bangalore, my faculty, right? He was a part of my thesis committee, but a wonderful book he has written. If you go and check into Amazon, this is one of the bestsellers when it comes to your data science, right? You might would want to have a look at these books. Other than this, you also have this medium.com, Analytics Vidya, and YouTube, which are probably the other sources from where you can get this learnings. Okay, so let me proceed further. Data cleaning is the agenda for the day, right? And the first thing which you have, if you see on the screen, are 5 records. If you have been in the last class, we had started off with this, but yeah, we'll restart this particular one. 5 records, customer IDs are there: 1001, 1003, 1004, and 105, right? And the insurance amount is basically the target variable. Along with that, you have the zip code, the gender, income, age, marital status, right? Followed by. As I said, that insurance amount is my target variable, right? So my first question is that which all are the other variables which are there? Which all are the features which are there? Which all are the features which are there? Which all are the features which are out there? Which all are the features which are out there? Okay, some answers are coming up. All the apart other from the insurance amount. There is a uh, line, just so you can see, for example, your customer ID. Customer ID, though it comes in as a data point, can basically use it as a feature, right? If you see this thing, you can't use this as a feature, right? We can't use as feature, right? So basically, you have a target attribute, which is your insurance amount. That is your target attribute. And then you also have non-target attributes. So all this customer ID, zip, gender, income, age, marital status, they are the non-target attributes, right? They are the non-target attributes. Now, within this non-target attributes, there are some which are basically the features, right? In this non-target attributes, there will be some features which are basically, I'll tell you, so, which would basically be your gender, definitely, income, yes, age, yes, and marital status, right? Okay, gender, income, age, and marital status. Wonderful, right? So the other thing is, so Sachin, what about this zip code? What about this zip code? Can I take this zip code as a attribute? What do you think? As a feature? What is your take on this? What is your take on this? Not to consider. Okay, so I'll tell you something. See, there are multiple viewpoints for this very part. Zip code, I'm with you. That zip code in its current state, which is there, it is probably not an indicative of any feature, right? But but if you can map this zip code to the regions, right? Maybe some zip code maybe refers to some places, let's say in Beverly Hills. Some zip code might be with, let's say, the Bandra Hills area in Mumbai, right? Some zip code uh, might be with some other locations. Now, what you can do is zip code on its own is probably not useful, but you can actually use the zip code to extend the value of the data. In the sense, if you are, let's say, you are finding out the zip code, and then you are plotting the region where this particular area is. And if you can get some kind of idea about the, let's say, the average income of people in this particular area, right? Or maybe you can probably have some categories like, okay, this is a high income area, or this is probably a middle income area. This is a low income area. So what happens is that with the help of zip code, you can actually augment the data, right? So coming back to our discussion, I agree with Sachin that zip code we can't use as a feature. This can't be used as a feature, either the customer ID, but yes, some cases we can use some augmented value. And then the customer ID, right? So here the ID information doesn't give any further information. In some cases, your ID also is encoded in some formats, like when on in which particular year probably this employee had joined, right? This customer had been acquired. Let's say 1001 1, 1002 21, 1003 23, 1004 say 19, 1005 12, right? If we know some additional information, so what I can do is I can probably strip off this particular part. And then from this, I can derive that how long the customer is associated, right? So this is probably also something that we can find out, that how long is the customer associated with this particular brand, right? So again, once again, these are feature engineering where the native feature I probably can't use, but I can augment the native feature with some other feature, right? Fair enough. But yes, gender, income, age, marital status, these are the ones, and insurance amount is the target, right? Now, coming back, I think I'm sure that you remember what we had discussed in the last session, where we said that in the first row, age C, problematic, why age is C, right? In the next case, you said zip code alphanumeric, why it is alphanumeric, that's a problem. Also, this income part, right? Problem. In the third row, Gender is missing. That's a big problem. Also, in income amount, if you see, exorbitantly high amount, right? So age 45 customer, I don't know what this stands for. 1004, this one, 6269. You can see one thing, that all the other zip codes are 5 or more. This one is having 4. Problem, right? And gender is fine, income is fine, age 0. Big problem, right? Someone with an age 0 having an income of 50,000, right? So unless maybe that person is a relative of or probably the grandson or granddaughter of Mr. Ambani, someone with a age 0 and having that income, problematic. Also, if you see this 2S which are there, right? This S, what might happen is that this S can stand for single or separated. This S can stand for both single as well as separated. So for the age 0, I would like to assume, fair enough assumption, that it will be single, but the age 45 can be single as well as separated. I don't know. Right? So that's a problem. Also, I think one pointer which you showed up, Subramania, was that this income part, yes, while all the other incomes they have a trailing 0, right? This one has 999, right? So probably we'll have to relook at the format and the structure, right? These are some of the problems that we saw. Now let's come to what caused all these problems. Coming to the first one, age C. Definitely it's a problem, but how come this problem arose in the first place? Now, let's say that you are in Japan. So in Japan, it is very common for you to find people with age, who are pretty healthy and strong. And the age, right, is, let's say, more than 100. It's pretty common, very, very common, in fact, right? Age more than 100 for this kind of people. In India, probably, you'll find way less people like that, right? Though there can be exceptions. Now, what happens is that whenever in Japanese banks, right, when they had designed the databases, they probably kept a provision of 3 characters for age, right? Assuming that their age probably can go from 10 to, let's say, 120, something like this. They kept a provision of 3 characters. Now, see this data that we are seeing, right? It comes from some data warehouse. And data warehouse, what the data warehouse now does is that it creates the data from across all the different databases. And someone who probably had designed this particular database, right, this data warehouse, he or she had assumed that age thing will probably have up to 99. So the character was limited only to 2. Now, when the age was to be imported out in this particular field, so giving some error, right? Obviously, it is not allowing this 3 characters, right? And let's say someone with an age of, let's say, 112. So if it was taking the leading 2 characters, it would have become 11. If it would have taken the trailing 2 characters, it would have become 12, right? So the person who probably was in charge of getting the data into the system, he or she need to do something around it, right? One solution might have been that, okay, you throttle this to 99. But maybe this smart person, what he or she thought was that, let me give an indicator C for the age. C means centurion, right? And then with this assumption, this particular person went ahead. Now, what happened in the process was that the person was able to import this data into the system. 2 characters was required. He or she used 1 character. But for someone like you, when you are looking at the data and trying to do analysis, it's a nightmare for you. You probably will have to go back all the way to the source system to find out what exactly was the problem. And then you find out that probably the age was 112. And then when you try to once again rectify this age, you find that, okay, here, so it allows only 2 characters, then probably you'll have to change the dimension of the age field altogether. A lot of problems are there. That is the case of the first age. Come to the second one, zip code alphanumeric. You are saying that looks that it is probably incorrect. Prima facie, if I look into all the other parts of the data, right, it might look as probably a problem. But you know the thing is that actually in some places, in Middle East, in old British Columbia, in Canada also, alphanumeric zip codes are actually there, right? So though this is not at par with the other parts of the data, but the thing is that this is actually a real data. Fine. Okay, come to the other part, which is the income. The income is coming as minus 40,000. Problem once again, right? Now, what could have caused this particular problem, right? So here also, the thing is that, right, there are 2 ways of looking at it, right? So someone might have taken a loan from the organization, right? Loan from the organization, and let's say 1 lakh rupees, right? 1 lakh rupees loan was taken, 100,000 rupees loan was taken, right? And probably this person thought that, okay, every month I'll probably pay back, let's say around 20,000 of it, right? And maybe in the salary slip or whatsoever, the income in the first month came as minus 80,000 after deducting the 20,000 from the income. Next month it probably came as minus 60,000 and then minus 40,000. Right? So like this, probably it was coming up. It's again problem, right? So that is one way in which this particular problem could have arisen, right? The other way of this problem might have arisen is that, see, as I said, that these data warehouses, many different source systems contribute to this data. So probably the data was in the format of, let's say it's a global bank, right? So maybe some yen 40,000 was there. And in the target database, target data warehouse, the only character which is permissible in this particular income field is a minus. So this particular dollar sign or whatever it was there, yen sign, what was there, it got converted to this minus because that was the only permissible character. Whatever it is, it's a problem for people like you, people like us, who are probably trying to do some data mining with this. Okay, that is with the second one. Come to the third one, right? Zip code is fine. Gender is missing. Gender is missing, right? Because that if gender is missing, you can't do much about it, right? Now, what could have caused it? Sometimes data is not there, right? And then, right? It's just very recently that all these data entry forms, they also have provision for a transgender or third gender or things like prefer not to say. Earlier, it was very hard coded, male or female. So it is not matching with any of it, or probably someone had not put in the value, it came out as a blank, right? Also, the other way of looking at it is that some other value might have been used. Maybe someone had tried to put in the entire of male into this particular field, but this particular field is taking only 1 character, so that got truncated completely. So all these are some of the problems which might have happened. Income here, exorbitant high amount, right? I might not have been too much bothered about this particular income, but right, my target variable is this insurance amount, and this insurance amount, if you see, I see the person who's having the highest income having the lowest insurance amount. That is fishy. That is fishy, right? So, mark out here. Come to the fourth one. Zip code comes as 4 characters. Once again, in some parts of British Columbia, you find 4-character zip code. Also, many a time what happens is, see, all this data are coming from different systems. Zip code typically being numeric field, most of the cases, maybe it was marked as a numeric field. If it's marked as a numeric field, what happens is that even if, let's say, there was a leading zero which was out here, that probably would have got truncated. It is not allowing this leading zero, whatever it is. Once again, problem. This leading zero was a problem, right? It truncated, and that's how it came up, but it became inconsistent with the data. Also, the age 0, how come age is 0, right? Age 0 is still fine, but age 0 with the income of 1,000 is where it is suspicious, right? Age 0 with the income of 50,000 is suspicious. Once again, I can tell you there might be several theories behind this, right? One of the plausible theory is that, once again, let's say the age was probably 100 in some case, right? It only took probably the last 2 characters, someone, right? Because this comes from different systems, right? Whenever it is inputted. And when it took the last 2 characters, came out as 0, that's why it is 0. Problematic, right? So this is the age 0 part. Marital status, as I said, this 2 S's has to be done something around it. It can be single or separated. And the last case, as we see, that this is probably not at par with the other parts of the data, right? See, only 5 rows of data is what we are looking at. Only 5 rows of data, and so many different possibilities we are already talking about just from 5 rows of data. So imagine if the amount of data increases, right? The kind of challenges that you might face. So remember, in the last class, where I was showing you the fallacies of data mining, right? I'll just show you once again that particular part. The fallacies. Automatically cleans data in databases. Automatically cleans data. So now you know that if I'm saying that automatically data cleaning will happen, how difficult it is. Right? I hope you understand that. Right? Let's move ahead. So okay, as I said, that in Canada, right, it actually uses this alphanumeric zip code that was there. 4-digit New England states, leading 0 truncated, right? Database filled numeric and chopped off leading 0, right? Now the problems, income filled, very high values, right? Probably an outlier, or again, as I said, that sometimes it might be valid as well. My question to you, right? My question to you is that how to counter this kind of situations, right? What can we do, or what should we do to counter this kind of a situation? Right? Let me throw this question to you. See, I think since only 2 people are there in the class, let me do one thing. Let me just give you the permission to talk to both of you. And what I'll request is that whenever you have some question, you just raise your hand. I think there is this thing where you can, I think, raise hand. If you go to the more part, you can actually do a raise hand, and I'll probably answer your question. So yeah. So Sachin and Subramania, my question to you, right? So first question is to Sachin. So Sachin, in an organization, which all people will be having very high salary? This is a question to Sachin.
Can you repeat, sir?
Yeah, my question to you is that in an organization, right? I'm sure that you are also working in an organization. Are all the people having the same kind of a salary, or there are some people who are having very high salaries?
No, every people there's a different structure for the salary for each people.
for each people, right? So who are the people who are having very high salaries?
Mostly management persons have
The
high
management person,
salaries.
sure.
Yeah,
The CEO, CXO, those kind of people, they're having a very high salary.
correct.
My question to Subramania is, are there people who are having extremely low salaries in the organization?
It can
Extremely low.
be above 15,000 or like that.
Extremely low salary, right? 50,000 is still a decent salary.
15, 1 5.
1.5, right? So
Yes,
actually this kind of people.
because as per the Indian law, it should be the minimum. That is why.
Okay, so I'll give you the example. So probably people like interns, they'll be having very low salary, right?
Yeah.
Also,
Yeah.
people like the blue collar workers. So in many cases, the blue
Yes.
collar workers, they're also part of the workforce. So their salaries are also very, very less.
Yes.
Now, coming back to the income field, right? What happens is that this high value can actually be a valid value, right? But what happens is that for values like this, the whole calculation, the whole system is in for toss. So what we can do out here, is that we can probably use some kind of a flag variable, right? Flag variable. Maybe I can introduce a Subramania. You can just turn off your mic, right? Yeah.
Yes.
So we can have probably customer category, where I'm saying all the others are regular customer. Maybe this is a blue collar customer taking a very high loan. This is a CXO customer, CEO level CXO customer, regular customer, regular customer. So once again, when I look into the additional information, I'm actually able to make the data more enriched, right? So this is what I'm been doing out here, right? I hope you got the idea, got the point, right? So yeah, I think we have discussed all this. The marital status contains yes. So those are the problem parts which are there, right? So now, as you can already understand, that if you have data like this, it is very difficult to create some kind of a models, sorry, or even some kind of analysis with the data like this. So what we can do is that we can resort to data pre-processing. We can resort to data pre-processing. So what happens in the data pre-processing, right? As you can understand, this raw data is incomplete, noisy. It contains all these obsolete fields, missing values, outliers. It's not suitable for doing any data mining. Values are erroneous. All these problems are there in the data, right? If you don't clean the data, it probably will be a very difficult task for you. So what we can do around this, right? So we probably have to do some kind of a data cleaning, data transformation, right? In order to achieve that. And what might happen is I've already given you several examples, right? Many other cases like data is not relevant, missing, data is expired, right? Say, for example, you are trying to predict the gold prices of, let's say, the next week. And if you're using 10 years back gold prices, it's not having any value, expired, right? Values are not looked into 12 years, expired, not relevant. So these are the problem. And see, if you remember, when I spoke about machine learning, the thing with machine learning was that machine learning uses the same kind of a learning mechanisms which we use. Now, think about yourself, right? Let me take you back to the days when you were also a student, right? You were also a student, and before the exams, you always look for suggestions, right? Now, if there was some friend who probably would have given you irrelevant things that ye pad le, ye pad le. This one is very useful or interesting for the exams. So the more garbage you get in exam hall, right? You see that there's nothing common. So you also spill out garbage on the exam paper, isn't it? Right? So like that. If you want to do machine learning, you also should try to minimize the amount of garbage in your data, right? The garbage input is minimized, right? Then the learning becomes better, right? And then Pal, right, a famous researcher, he said that data preparation 60% of the effort for data mining process, right? I'll beg to differ, right? The preparation is the minimum 60% of the effort for data mining process. And it can go as high as 90%. But this is something without which you can't do much. Right? Okay, let's move ahead. So, handling missing data. How we can handle this missing data? So, both of you, I hope you have attended the statistics classes, right? And I hope you have studied things like central tendency and dispersion. I hope you have studied. Yes, no, maybe.
Yes, sir.
Studied, right? So missing values poses a problem to data analysis method. Right? So either you need to probably clean the missing values, or probably you need to remove it. There are no other options. So there are actually some rule of thumb for doing it. Typically, if you find that in your entire data set, less than 5% is missing, just go ahead and drop it. You will do yourself a lot of favor by dropping these values. Right? Less than 5% missing is there. Just go ahead and drop this particular piece. Right? Now, the thing is that if it's more than 5%, right? So then if you again go on and dropping missing values, right? What will happen is that you might not be having enough data itself to probably do analysis, right? So then what will happen is that you will actually have to do data imputation.
Actually, in statistics, I remember because it was very important for me as well that time. So we have taken the repetitive. What is the number which is repetitive? One thing, and second thing was the missing data is average of the remaining numbers.
Sure,
That way also.
I'll come to that. Don't worry.
Yes, sir.
Okay. So missing value is less than 5%. As I said, that just go ahead and delete it, right, and save yourself from all this trouble. If it's more than 5%, you probably can't go ahead and delete it. So then what you have to do is that is averaging. So for numerical data, what you can do is you can use the mean or average, or you can also use the median, right? This is what probably you can do for the numeric data. For categorical data, where there are categories, so obviously you can't have a mean or median. So there you basically look at the mode. And if you remember, mode is basically the value which is maximum. So categorical data, look into the mode max occurring data, right? Sorry, what happened just happened. Don't know. Just a moment. The screen coming out properly for you guys? Just a moment. Screen is showing properly, or there are some other windows which are showing up?
Yes, it's
screen is showing properly.
Screen is showing properly, right? Just something happened in my screen. Just a moment. Just a Okay. Just okay. Fine. Screen is proper, right? No issues with the screen as of now. Guys, screen is fine, right?
Yes,
Hello?
sir, no issues.
No issues.
But I think if you write something which cannot be moved, like it is
Just
stuck
a,
in between.
just a moment. Just see.
Yes, sir, we can see.
You can see, right? Yeah, fair enough.
Yes.
Okay. So, as I said, at the missing values, to do some kind of a careful analysis, right? For numeric, use mean or median. For categorical, use mode, right? So these are probably some of the things that you need to do, right? So let's see at what can be done out here. So out here, this is a famous data set for cars, and you can see the data. One is MPG, which is the miles per gallon. The other is a cylinder, number of cylinders which are there, cubic inches, and then these are probably some of the things which are there. And you can see the cylinders, they are, see, right? My question to you is that, right, what kind of a value is it? Value which is missing, what kind of value is it? Is it numeric, non-numeric? What do you think?
It's numeric only.
Numeric only, right?
Yes, yes.
Okay, Aniket is also doing numeric. See the definition, data definition. If you see the data definition, it is not numeric. It is actually categorical, right? So car cylinders, you have like 2-cylinder car, 4-cylinder car, 8-cylinder car, like that, right? Basically, these are categories, right? So though it is represented number, but it's nothing but categories, right? Say for example, things like your zip code, right? Those zip code, it's represented in some numeric format, but actually it is not numeric. It is some kind of a categories only which are out there, right? So this is categorical. And now for categorical, what you are supposed to do is you are probably, what will you do for replace, I mean, with this categorical value? What will you do? How will you manage this missing values? We have just discussed.
By average mean.
Categorical values. Categorical values are non-numeric values. Non-numeric values, you are going to replace that with or the value which is maximum operating, right? Similarly, let's look into other parts. Cubic inches. So cubic inches, it's a continuous value, numeric value. So you can replace this value with the average. This values also can be replaced with the average. And then horsepower continuous, that can also be replaced with the average value, right? Let's do the replacement and let's see what comes up. Okay, so I have done the replacement. And here are the replaced values. But now that how good a job we have done. How good a job we have done. Okay, so the mode of the categorical field is 4. So all the cylinder values, they have got replaced with this categorical value of 4, right? Right? This all replacement has happened, right? Let's look into some real values. So this is a car with cylinder 4. This is a car with cylinder 4. Typically, a car with cylinder 4, small car, cubic inches, you can see very small, 89. And the horsepower is 71, right? So basically, small efficient cars is what we are looking at. Now, what we have done is, because this was the value which was mostly occurring in the data, so we have used this value to replace all the other values. Now see the problem that we have created in the process. In the process, since we have done this placement, what has happened is that, see, car with a cubic inches of cylinder of 4 cubic inches, 400. So 400 cubic inches, if you see the data, it probably is for cars which are 8-cylinder and above. Now, after you've done the data imputation, what has happened is that it is giving you a complete wrong picture, right? Okay. Also, the other part, if you see, this one is a car of cylinder 4. The cubic inches here, it is 200, right? Because we have used an average value, which once again is problematic, because again the value was 89 out here. And see the horsepower. So horsepower for this 4-cylinder cars are always like this 71, 62. What we are having, right? We can understand the complete disbalance which has crept into the data, right? So out here also you can see that, yeah, this is 350, 351, 125, 158. Like this kind of a values we have got the picture, right? Come to this one, car cylinder 8. So this value was okay. Cubic inches was missing. We have replaced that with 200. So this is probably around half of the, or not half, right? But again, almost 1/3 less than the actual values which are out there, right? So we have done the imputation, but you can already understand the kind of problem that has gone into the data. And with problems like this, what will happen is that your issue will only only become more prominent, right? And the model itself will be completely unstable, right? So yeah, as I said, yeah.
I have one question that below
Please.
sheet.
Please. So
Actually,
Subramania,
if
just
we
a request.
see the first, yes,
Yeah.
sir.
Just a request.
Yeah.
Whenever you're asking question, just use this raise hand thing, right? It becomes easy for me also.
Okay, sorry.
Right?
Yes,
Yeah,
sorry.
yeah. Go on, go on. Yeah, go on. Tell me.
Yes, sir. If we look at the first column, MPG.
MPG, miles per gallon. Yes.
Yes. From there, we can see few are related to the cylinder category. What it has 8, 4, and 5, which is
Sure.
similar. And again, we can compare with cubic inches and HP. Based on that, we can arrive.
Sure. That's
Cylinder.
a very great observation that you have made. So actually, I was coming to that. See this miles per gallon.
One thing is in row number 3, 517, which is
517.
also
What is this?
different number than the
Exactly.
other.
So this miles per gallon, that is basically my target variable. So whenever I'm creating this particular model based on my cylinder of the car, based on the cubic inches of the car and the horsepower, I'm basically trying to predict that what kind of a miles per gallon this will give me. Now that is my task. And then what I'm doing on the other hand side is that using this to predict the features, right? You can understand that the whole process, right? There can be some kind of a disbalance in this whole, right? So yeah. Let me go ahead. Let me move ahead with this one. And again, this was also a good identification, 517 miles per gallon, 517. Right? I think Elon Musk will be very happy if he can get this kind of a model out on the street. So typically, as I said, that this mean or median or mode sometimes works well, right? And typically, right, see, if you have some values which are very high, right, going back to the previous data, right, if I'm trying to find out that what is the average miles per gallon of the car, average miles per gallon, this particular value, which you might already understand that it is probably an outlier, extreme value, this value is shooting up all the other miles per gallon values, right? It is probably pushing the miles per gallon value for all the others, right? So sometimes mean is not a good indication. There, generally for numerical data, I at least suggest that you use the median, right? So median is a much better indicator compared to mean, right? And yeah, you can probably consult some domain experts, right, to understand that, okay, what approach you should take to replace the missing values, right? That is something that you can do, right? Okay. Let's move ahead. Right. The other thing that you can do is sometimes you can also replace these values with some random values from a distribution. As you were saying, that we can look into the underlying patterns. We can look into the underlying patterns and try to give some of these values, underlying patterns, and try to give some of these values. Yeah. That's also a possibility. That's also a possibility, right? Okay. So as I said that sometimes, right, all the things that we have said, it comes into the picture, right? That sometimes you're destabilizing the data, right? And it is probably giving rise to some kind of a Frankenstein kind of cars, which probably does not exist. Still, it is there in the system. So these are some of the problems when you handle all this missing data or you do the imputation. But as I said, that unfortunately, this missing data, right, has to be worked with. Otherwise, what will happen is that again, you probably get some kind of a destabilization in the data, right? Okay. The other thing is that identifying this misclassifications. Misclassifications. You see these countries, USA, France, US, Europe, Japan, right? So are everything fine, or you see some problems? Is everything good, or you sense that there are some issues? It's very simple. The first one is that US and USA are the same, right? Because a different identifier has been used, a different category gets created. So probably we need to drop the A from USA and make it to US. So this two will probably become 157. Come to the next one, right? See, you already know that France is probably a part of Europe. Then we are having France separately, Europe separately. Why? Also probably can be joined to make this 47. Isn't it? Now, the problem which is there is that here too you have the domain knowledge, right? You all actually understood that US and US, they're the same. France can be a part of Europe. You already have the domain knowledge. In real life, what might so happen is that you have been given data and you don't have much idea about this whole data. And because you're not having much idea about this data, what might happen is that you will not be even able to understand that some of these fields, they actually are the same ones. So that's why it's always a good idea that whenever you're getting your data, always cross-check with some kind of a domain experts. That is probably very, very important. Right? Okay. Let's move ahead. Right? So this outliers are extreme values. Right? These are the values which lie near the extreme limits of the data range. And sometimes they indeed represent the errors in the data entry. They represent the errors in the data entry process. Right? So let me show you. For example, this is the car weights. There's some cars, very light cars, right? Made of paper or plastic cars, right? It's pretty incredible, right? So these values are probably not correct, right? And if we do some kind of a graphical analysis, we should be able to find some of this out. See, for example, here, this one car value is basically 192.5, right? Pretty impossible to have a car of 192.5 kilos. So, or not kilos. Okay, by the way, this is pounds. So 192.5 pounds is probably my weight only, right? No, probably a little more than my weight. Somewhere around someone with, let's say around, how much I'll say, maybe 95 kilos approx, right? But again, that can't be the weight of a car, right? So what might have happened is that maybe this point which is coming, that has probably come by mistake. It probably would have been 1925. By mistake, it came out as 192.5. So these are some challenges which are there in data, right? Once you identify this kind of situations, what you can probably do is you can probably check with a domain expert and probably get some kind of a validation, right? That whether you should keep this data or not, right? Try to do, right? Also, this outliers, right? Some of this graphical methods, right? So weights, as you can see, right? Low weight. This is something that we have very high miles per gallon, right? So just from the data itself, you can actually you're actually able to find this kind of things out, right? So that brings me to the measure of central tendency, right? So where what we are doing is we are basically measuring the central location of the data, numerical summaries, right? As to where the data is on the number line, right? So mean, median, mode, I've already discussed this, right? And as I've said that mean is probably not the great measure, right? So for extremely skewed data, for data which is extremely skewed, mean becomes a less important variable for the data, right? And mean, as I've shown you, that it is very sensitive if there are some outlier values which are there. So that's why rather than using the mean, it's always advisable that you probably use the median. Rather than the mean, use the median so that this median is able to handle the extremities, right? This median, they basically will be resistant to the presence of all these outliers, right? Okay. So another measure is the mode, right? And mode, what it represents is the fill value which is occurring with the greatest or the highest, right? Okay. Mode can be used on either numerical or on categorical data. With both, it can be used. But generally, we don't use mode that much for the numerical. For categorical, yeah, we probably use the mode to a greater extent. For categorical data, we probably use the mode, right? Not generally for the numerical data, right? Okay. The other is this measures of variation, right? So measures of variation typically is how much the data is varying. So for that, the standard deviation is one of the ones which are being used. Standard deviation, right? So standard deviation is most widespread measure of variability. That is what we have, right? And it can be interpreted typically as the typical distance between a field and the mean value. Right, so you have already done standard deviation. So if your data is very consistent, then probably no problem with deviation. Data is not very consistent, right? Then probably standard becomes deviation becomes very high, right? Okay. Other is to do with the data transformation, right? So what happens is sometimes these variables, they tend to have ranges which are very different from each ranges different from each other. Just look into this one. In baseball, one is this batting average and the other is this home runs. Both of them, they have very different skills, right? Now, when you have data like this, what might so happen is that the variable, right, the number of home runs, it will probably have more effect on the entire piece, right? More effect on the model compared to the batting average, where it is probably much on the lesser side, right? So this is what happens, right? So here, what we do is that for numeric field, we try to do something called as a normalization for the numeric. Okay. Now, anyone, any idea about this normalization? What exactly is this normalization? Yeah, 3 people who are there in the class. Any idea about this normalization piece? What exactly is this normalization?
Yeah, Sachin, yes, sir. We are trying to, you know, uh, make metrics, I mean, in the same scale, the same value,
Uh-huh.
mostly by applying the standardizing scaling techniques.
Okay, no, no. But again, I mean, what you're saying, can you just explain that in very simple terms? What exactly it's standardizing or normalizing mean?
Uh, Normally, I've seen the standardizing where we use algorithm
Uh-huh.
to make the value at same level. For
Okay.
example, in one parameter we have a like 1 2 4 5 6. In other parameter we have a 0 point something something. Then
Okay.
we can make these both the fields in a same range or
Okay.
same value range. Yeah.
Okay. Fine. Fair enough. Fair enough. So what we do with the normalization part is, as you rightly said, that we try to bring it in a level where at least the scale is the same, right? There is not too much of a variation. So the first thing that I'll talk about is something called as a mean max, right? So what is a mean max normalization? It basically right gives a like puts in some kind of a threshold both on the minimum value as well as the maximum value, right? So for example, let me talk about let's say for age vis-a-vis your weight, right? So again, without any bias, right? what we might see is that in this particular class, they are very low participation today. The class I've seen that for people, right? It typically had people between ages of 20 to as high as 48. So that's the range which is there, right? 20 to 48 is basically 28. Now, if I look into, let's say, the other thing, which is, let's say, your salary, very big, probably the variation is much higher. If I look into your weights, maybe the variation in the weights are probably much lower. Maybe the variation will be, just assuming, around 15, right? So in this mean max normalization, what we are trying to do is that we are trying to throttle the values between the upper and the lower, right? The typical formula for mean max normalization is x minus minimum of x divided by range of x, right? So what does it mean? So let me give some values, some example. So let's say that these are some of the values which are given here: 2, 4, 6, 8, and let's say 10. And then another set of values are, let's say, 100, 110, 120, 160, 180. If I'm doing a min max normalization, what I'm going to do is that from each of the data points, I'm first going to subtract the minimum value, right? So let's do the subtraction. So this becomes 0, this is 2, this is 4, this is 6, and 8. This also becomes 0, 10, 20, 60, and then 80. I've subtracted the minimum value. And then once I've subtracted the minimum value from the data, I'll divide by the range of the data, right? So my question to Aniket. Aniket, what is the range for the second data series which I've given? What's the range for this? Yeah, Aniket? Aniket has already given me the answer. It is 80. Okay. And Subramania, what's the range for the first data? What's the range for the first one? That's the, see, 2 to 10 is basically the scale of the data. The range is 10 minus 2, 8. Right? So then the next thing is that I'm going to divide this data, right, by this particular range. Now in the process, what will happen is that 0 divided by 8 would be 0. 2 divided by 8 will be 2 by 8, 1 by 4, 0.25. 4 divided by 8 will be 0.5. 6 divided by 8 will be 0.75. 8 divided by 8 will be 1. Likewise here, right, 0 divided by 80, 0. 10 divided by 80 is 1 by 8 or 0.125. 20 divided by 8 is 1 by 4 or 0.25. 60 divided by 80 is 3 by 4 or 0.75. 80 divided by 80 is. See, the data were there in different scales, but how I have successfully, we have converted that into the same range. So that was the mean max normalization for you. Right? So other is this something called as a Z-score. Z-score. In your statistics, you might have heard of this Z-score, right? Z-score, what we do is that from the data points, sorry, we subtract the mean and then divide it by the standard deviation. We subtract the mean and divide it by the standard deviation, right? Basically, x minus mu by sigma, where mu is the mean and sigma is the standard deviation. So let me just give you once again same kind of example. Let's say 2, 4, 6, 8, 10. As you can understand, the mean or average of this is 6, right? So let me subtract 6 from each of these data points. So this becomes -4, -2, 0, 2, and now if I add up this thing, right, after doing this subtraction, after subtracting the mean value, if I add this thing up, -4, -2, 0, 2, 4, if I add this up, the summation becomes 0. So 0 divided by whatever, 1, 2, 3, 4, 5, 5 data points is there. Even if there were 50 or 100, 0 divided by 50 or 100, it will be 0, right? So the mean value, it becomes 0 for this particular distribution. Whereas the standard deviation, right? The standard deviation, let's say the standard deviation here, let's say if it was something like maybe a standard deviation of 2, if I take, right? So I have not calculated, the standard deviation will actually be more than 2, I think. Take that as the standard deviation. Then if I divide the mean by this standard deviation, so this will become -2, -1, 0, 1, and 2. This becomes my data after doing this z-score standardization, right? I hope you have understood, right? So z-score standardization, right? And this is the formula, right? Okay. By the way, for the min-max standardization, the value generally, right? If you use the default, it is between 0 to 1. For the z-score standardization, by the way, theoretically, the value can go from -infinity to +infinity. Theoretically, but typically you will find that the value lies between -3 to +3. For the z-score value, typically the z-score lies between -3 to +3, right? If the value is less than -3 or more than +3, such values are treated as outliers. The value is less than -3 or more than +3, these values are treated as outliers, right? Okay. So let me revisit some of the features, right? Remember, this was the data set that we were using, right? And I told you that this is the famous iris data set, right? And here, right, I was just giving you the idea about the attributes versus the features, right? So attribute, you can have a target attribute and non-target attribute. In this data set, this one is the target attribute, and this one is the non-target attribute. So one is the target vis-a-vis the other is the non-target attribute, right? So generally, right, I think as a good practice, what you should do is only the features which are making sense for your modeling. So only the attributes which are making sense, not the features, right? Once again, mind the language. Only the features which are making sense or meaningful to the attributes, to your machine learning modeling, that you should take as a features, right? Not take anyone else as it, right? Okay, let's move ahead. So feature engineering, right? Feature engineering is a very important pre-processing step in the machine learning part. Very important step in the machine learning part is feature engineering, right? So feature engineering, what you do is all this feature transformation or a subset of the feature selection, all this comes into the feature engineering part. So remember in our data set, when we said that we are not going to use, right? We are not going to use all those things like the record number, zip code. So that basically comes under feature subsystem. Feature transformation, your standardization, normalization, all this comes as part of the feature transformation part, right? So feature transformation also, you can have two variants of feature transformation. One is feature construction, other is the feature extraction, right? So let me give you an example, right? So let's say you are trying to purchase an apartment, right? A flat in whatever city you are in, right? So what will be the features which will determine the price of the flat? Right? You can give some answers on the chat. What will be the features which will determine the price of the flat? You can give some answer on the chat. I'll just jot it down. Features which will basically determine the price of the flat. Aniket is saying location. Wonderful. What else? Area. Very good. So area means the area of the flat, right? Well, size, right? So size of the flat, built up area, right? Size, a location, right? Location, size, size, which is covered area, and 3 amenities. These are roughly the 3 most important things that will determine the price of this apartment, right? Now, let's say you have been given a data, which this the data that you're having. You have got the length of the apartment and the breadth of the apartment. Apartment length and apartment breadth is what you're having, right? And you're trying to basically determine the apartment price. Now the problem which is there is that neither the length nor the breadth will probably represent the price in a good manner. But again, if you talk to a domain expert, the domain expert will say that rather than the length and the breadth, if we can use, let's say, the area, that probably will be having a very important correlation with this particular price, right? So rather than the length and the breadth, if you can multiply the length and breadth to get the area, that probably will help you get the price, right? Okay. The other one is that. What about, so you have already talked about the numerical variables. We have already talked about how to do a normalization, right? We also spoke about the variable construction, all those things. Now, what to do with this categorical variable? Now, unfortunately, right? See, you might think that this machines, right? You might think that this machines can understand categories, right? These days, you see all this chat GPT, they are doing a wonderful job, right? You might think that, okay, I mean, machines understand these categories, but wrong. Machines are probably as dumb as they can be. As dumb as they can be. We basically teach these machines, right? We basically teach these machines, right, as to how to process data. Now, let's look at this particular part, city of origin. Now, city of origin, city A, city B, city C, we can make sense of it, but not the machine. We can make this sense, but not the machine. Then what we can do is that we can actually convert this to some kind of a categories, right? We can convert this to some kind of a categories. So So there are three categories, A, B, and C, and that's what I'm doing. So I created three variables: origin city A, origin city B, and origin city C. Three variables is what I've created. Now with these three variables, see how we have encoded the data. Whenever the city of origin is city A, I give a 1 out here. All the others are 0, 0. City B, so city A is 0, city B is 1, city C is 0. City B, once again, city B is 1, all the others are 0, 0. City A, once again, city A is 1, others are 0, 0. City C, city A is 0, city B is 0, city C is 1. And city B, once again, 0, 1, 0. That is how I've done the encoding. That is how I've done the encoding. The other part is this parent's athlete, whether the parent is an athlete or not. Right? Whether the parent itself is an athlete or not. So there are two values, yes and no. So what I can do is parent athlete yes and parent athlete no values. Parent athlete yes, this becomes 1. No, this becomes 0. No, so yes becomes 0. No becomes 1. Yes, so yes becomes 1. No becomes 0. No, so yes becomes 0. No becomes 1. So like that, we have done the encoding. Right? We have done the encoding in this particular fashion. Right? And now, right, machines are very good at understanding the math, right? Numbers. This data will pass to the machines, and machines will probably now do a fair enough job of it. Here is a question which I have to you. Is that I've told you earlier that all the values, right? So these are right now my entire feature set, by the way. And this is my target, by the way. This is basically my target. This is my target, and all the others are the features, right? So what we can do is that this particular target is there. So all the others, the age, city of origin, and the parent's athlete, that is basically going to determine the chance of winning, right? These are my features now. Transform features. Transform features. And these are my target. Now the problem is that, see, first of all, the target. So my same problem is having two targets. That is difficult to manage. That itself is difficult to manage. So what to do about this? So what we can do is this target part. If you see that rather than this having two variables, if I can have just, let me just drop this particular variable. If I just drop this particular variable, then we have just this win chance yes. So whenever win chance yes is y1, chance of winning is high. Whenever it is 0, which means that win chance is no. So rather than using two variables, I can achieve the same thing by use of one variable, right? Similarly, if you see, right, the same trick, right? So by the way, from this to this two, from this to this parents athlete part, right? All this, it is called one hot encoding. So this is called one hot encoding, right? Now the problem, as I said, that too many variables are getting created. If I can drop this one, well and good. Still, I can do. So Subramani, you have a question. I'll come to your question, right? I'll come to your question after I finish this. And then you have this parent athlete, yes and no. Why it have two variables? Let me just drop, let's say, this one. So parent athlete, yes, if it's 1, which means the parent was athlete, is parent athlete, yes, is 0, which means parent was not the athlete. So only one variable will be required for these two fields, parent athlete and chance of win. What about the city of origin? City of origin, by the way, we have created three variables, city of origin A, B, and C. A, B, and C. Now here also you see that if I drop one of the values, right? Let me pick up which one has more number of zeros. So yeah, I'll pick up this one, origin city A. Let me drop this one altogether. I've dropped this one. Once I have dropped this one, you'll find that origin city B is 0, C is 0. It means that it is not origin B, city B or C, which probably points it back to A, right? And then you have this one, origin city B as 1 and C as 0, which means the origin city is B. Origin city B as 1, C as 0. Origin city is once again B. Origin city B0, C0. So neither B nor C. It probably points back to origin city A, right? It probably points back to origin city A, right? So like that, what we can do is, rather than see here, you have, let's say, N1 categories. Here, let's say you have N2 categories, and here you have N3 categories, right? So then I might have ended up with, and this one was only one, this numeric, only one value I'll take. So I might have ended up with 1 plus N1 plus N2 plus N3 number of categories, right? Not categories, fields, right? So N1 has 3 values, N2 has 2 values, and N3 has 2. So 3 plus 1 is 4, 5, 6, 7, 8. So that's the exact number of values which I have out there. 1, 2, 3, 4, 5, 6, 8 values I have. But rather than doing that, as I can see that if I drop the first 3 minus 1, 2 minus 1, 2 minus 1. This is 2, this is 1, this is 1, and this is 1. So I can very well do with 1 plus 2 plus 1 plus 1. So 2 and 1, 3, 5 with 5 variables. Rather than using 8, I can 5. How? I drop this one. Let's say I drop this one, the first one. I drop the first. So even with a reduced number of feature set, I can still do well, right? And this particular process is called the dummification of the variables, right? Got the idea? I hope so. Subramania, let me come to your question now. Okay, so Subramania, you're saying that your question is answered. Very good, very good. Okay, fine. The other thing which I'll talk about is this converting this ordinal, these features to an ordinal feature. So let me show you another example. You have this marks in science, marks in maths, and then some kind of a grade has been given. Grade B, grade C, and grade A. Right? Grade B, B, A, D, this kind of grades are given, right? Based on the marks you have got. Now, see, grade, as you can see, it's a categorical field. A, B, C, D, they are all categorical fields. But you know for sure that this grades, whatever it is there, there's a natural ordering within them. Right? There's a natural ordering within them. Say, for example, A is basically probably the best grade, whereas D is the worst grade. So A is greater than B, right? A is probably more preferred than B, or A has a higher rank compared to B. B has a higher rank compared to C, and C has a higher rank compared to D. So if I start giving them ranks, so A is getting a rank of 1, B is getting a rank of 2, and C is getting a rank of 3, while D is getting a rank of 4. So if I would have used the encoding process, so I had 4 grades out here, I probably would have ended up creating 4 new variables. Rather than the encoding process, if I would have used the dummification process, right? So rather than having 4 variables, I probably would have ended up with 4 minus 1 or 3 variables. But here, since I know that there is a natural ordering in the features, rather than doing all that, I can just give them this ordering. And based on this particular ordering piece, I can give them these numbers. That makes my job so easier. right? Okay. And the other part which I'll show is this numerator category. So here you can see that this apartment area is there, this apartment price is there, right? So apartment price. Okay. So quick question to you. So let's say your apartment area is the feature and price is this the target. Target and feature. Feature and target. Feature and target. This is what you're having, right? This is the feature and this is the target. What class of problem is this in my machine learning lingo? What class of problem is this? In my machine learning lingo, what class of problem is this? I have a feature from which I'm trying to generate a target, right? My target. What kind of a problem is this? What kind of a problem is this? Come on, guys, you just had a quiz today. Anyone? See, my target, the answers come in. Regression, exactly. So my target, it is numeric. So basically, this is a regression problem. It's a supervised learning, which is a regression problem. Now, what I'm doing is that based on this particular target value, right, I'm giving some particular ranges. So let's say that more than 30,000 is high, 20,000 to 30,000 is medium, and less than 20,000 is low. So I am doing a encoding of this where more than 20,000 becomes this one, this medium, right? Then your less than 20,000 becomes low, more than 20,000 medium, less than 20,000 low, more than 30,000 becomes high. So then essentially a regression problem, I have converted that to a classification problem. A regression problem, I have converted that to a classification problem. And then since I also know that there is some kind of a natural ordering within the data, right? So whereas low is probably the lowest level, then followed by medium, followed by high. So if I just rank the prices from lowest to the highest, so 1, 2, and 3, those are probably the 3 ranking which is happening. 1, 2, and 3. These are the rankings which are happening, right? So once again, what I've done is I've probably converted this problem back to a regression problem because it is numeric once again. But see, the precision has got affected. The first case, I had exactly the apartment area could have been matched with the price. So here now, rather, what will happen is a range of apartment areas will probably get mapped to the price, right? So basically, the information, the data which was there, so we have basically compromised with the information. Some part of the information has got lost, right? Okay. So typically, the other thing that you do, right, whatever you've learned, so this process are being used to convert your text data to some vectors like this. This house was built, I'm feeling well. The theater has good movie, I'm feeling lonely. So all these kind of things, right? What I can do is that all the sentences, I can just convert that in each of these words. And whenever some particular word is coming to sentences, I'm just increasing these counts. Right? I'm increasing these counts. Right? This concept, I think this will come in your machine learning 3, some bit of this will come out here. So which is this feature construction or this vector representation that you see out here. Right? Okay. So roadmap for building the machine learning. Right? So the first part, right, even if you before you go to the modeling part, comes feature extraction, feature scaling. Subramania is saying not clear. Okay. Which particular part, Subramania? Which particular part? This one? This slide? Okay. So let me do one thing. So let's say I have some sentences. I am feeling lonely. This is a good day, right? So these are two sentences, right? So whenever we are basically converting the paragraph, text, even web pages to some kind of a vector notation, right? So then what happens is that, okay, this is my sentence one, this is my sentence two, right? So what I'm going to do is that I'm going to convert first, look into all the data which is there, right? So all the keywords which are there, by the way, when you taking these keywords, you replace the preposition and the articles. So a and the, right? Those kind of I, he, right? Those things you remove. So here I am feeling lonely. Just take the feeling and the lonely. So feeling lonely. These are the two keywords which are coming out. This is a great, good movie. So this good. So these are the different features which are there, right? Now let me look at sentence one. Sentence one, I am feeling lonely. So feeling one, lonely one, all this 0, 0, 0. This is a good movie. So feeling 0, lonely 0, this one, good one, big one. So like this, for each and every sentence, I have a vector notation, this, right? And see, whenever you see that people are looking at web pages which have similar content, right? Web pages which have probably stolen things from the other, right? And even for people who are writing, right? Finding out plagiarism, this is basically the method which have been taken. We are converting this to a vector notation, and then between these vectors, we are finding out, okay, how close one vector is to the other, right? So typically this comes in, as Sachin is saying, this exactly is used in NLP, text analytics. This are the pre-processing which you do in NLP, right? So Subramania, hope it is clear. NLP, natural language processing, right? So all your text analytics, right? Those are natural language processing, right? You have a bit of introduction to NLP, I think, in your term, in your third course, advanced machine learning, right? So I hope we can just move ahead with this. So finally, this is a roadmap for building your machine learning system, right? The first block, you can see this is the most important block, the pre-processing part. You do all these feature extractions, scaling, feature selection, dimension reduction, sampling, all this are done in the pre-processing part, right? And then will probably come the next part, which is the machine learning part, where you do the algorithm selection, you work with the algorithms, all that, right? And then finally, it will come the machine learning evaluations and the prediction part, right? Evaluation, how machine learning models are evaluated. Obviously, we are going to talk in this particular term only, right? Probably in your next class tomorrow, I'm going to talk about that. But yeah, I think what we can do is we can probably take what's the time? we can probably take a quick break right now. What do you say, guys? Right? Should we have this break? Should we have this break? Yes, no, or we should continue? Only 3 people are there. Yeah. So I see a majority of people saying yes. So right now in my clock, it is 8:42. Let's come back exactly at 8:55. Let's come back exactly at 8:55 and get ahead with this. Meantime, just probably share your feedback in the forms. It also helps us understand that where all you require support. Right? Please probably fill up this thing, the feedback form, and let's go for this particular break. We'll exactly come back at 8:55. Okay, so I'm just pausing my sharing. Right? Remind me to restart this once again. Okay, so by the way, one thing, guys, before we go for this break, see next week Saturday, we have Friday and Saturday we have classes, right? Friday evening we have class, right? Saturday, I think the Navratri and everything is starting, right? And looking at the participation, right? Only few people are there in the class. Just have a discussion within your group that can we possibly do this session in the morning, right? Just take this out, right? Otherwise, probably we will stick with the evening schedule. But my fear is that many of you might not even come. Already, the class size is reduced to only 3 participants, right? Many of you might even choose to drop that. So yeah, it will be good if you can send a note to your classmates that on the 21st, can we have this session in, let's say, the morning hour. Right. So with this, I'll go for this break and we'll exactly come back at 8:50. Break for all. Thank you so much. Break was useful to you. Back. It uh, we have to cover, right? I have covered now. Session 1 did cover what is ML, workflow of ML modeling, right? And we also covered types of ML modeling, right? When to use which model. We have all covered that. And then for pre-processing, how you pre-process numerical variables, categorical variables, normalization, standardization, interpretation, level encoding, gamification, all this have been covered. So also we know supervised learning, unsupervised learning, so things are covered. Let's probably step into the part of the algorithms. Starts with classification, right? And here is where fully go in algorithms part of machine learning. Let me give you a scenario. This particular flower shop wants to guess a customer's purchases from the most purchase. What the flower shop wants. A customer's purchase from similarity to most recent purchase. Right? Now, for this particular part, this was the last flower which was purchased. This was the last flower which was purchased. Now the question is that which all flowers or which flower the customer is most likely to buy. Right? What is your take on this? What is your take on this? What is your take on this? Which particular flower the customer is most likely to buy? What is your take on this? What is your take on this? Yeah, guys? Subramania is saying that by similar color. Okay, fair enough. So let me do one thing. Let me pick out some of the features, right? So you said color. So color is, by the way, is a feature. So let's first start by identifying the features are color. Someone said pattern, shape, good. Pattern, shape, anything else? Anything else? Anything else? Anything else? So let me do one thing. Let me give some kind of a identifier to, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Are the identities, right? Okay. So, guys, can you give me your choice of, let's say, the top 2 flowers which are matching? The top 2 flowers which are matching. Your choice. Your pick. Romani is saying 2 and 5. Okay, let me just give some kind of this thing. 2 and 5. 2 and 5. Okay. Anyone else? Anyone else? Guys, what are the others? Subramania, I'll just take two answers. You've given 2 and 5. So would you like to change 5 with 10? Would you like to change 5 with 10? Would you like to change 5 with 10, or you'll remain with 5? Okay. Yeah. What are the others? Aniket, Sachin. Aniket, Sachin, what are your take on this? Aniket, Sachin, what are your take on this? Sachin is saying 10. Okay. Sachin is saying 10. Okay. Anyone else? Aniket, what is your take? What is your take? What is your take? What is your take? Okay, so let's try to demystify. Right, this flower has color, pattern, and shape. Right. So let's first look at the shape part. This is S, S, S. This 4 probably matches the shape part. Let's look at the pattern part. Right. Pattern, I'm looking at the pattern of both the inside as well as the outside. So pattern I and pattern I is for inside, O for outside. So pattern inside, if you see, I'll just mark it as I. Inside I, this one matches. This one matches. Right. And I'll give you a double I if the color is the same, double I if the color is the same, and a single I if the color is the different. So double I for the cases where the color was the same for the insides, was yellow type, right? In fact, if I see this one will also get an I, this one will also get an I, right? And a single I for when it doesn't match the color. So it's I, this one is I, and this one is also I. Right? Okay. So I'm done with this thing, shape. I'm done with the color, right? And so pattern inside I've marked, pattern outside I'll mark with a O. Pattern outside this definitely matches, right? This definitely matches, right? So where the outside matches with the color also, I'll probably give a double O. So here you can see the fringes, it matches with this one. This one is also O, O, right? And outside this is O. And color. So all this also, the color part matched, right? The color part, this matched, right? Color part, this one is matching. Color part, this one is matching. I think we're done. We are done. In fact, color part, this one is also matching for the inside part. So now let's take a tally of where all the maximum matches were there. And see, I think Subramania and Sachin, both of you probably rooted for 10. So 10 actually has the highest number of attributes, right? 1, 2, 3, 4, 5, 6. 6 matches. Vis-a-vis, this one had 4 and this one had 1, 2, 3, 4, 5. So 2 had 5 matches, whereas 10 had 6 matches. Whereas for 5, which I think Subramania gave, so Subramania, unfortunately, 5 had only 1 match, which nothing else. Right? So guys, I hope you got the idea that, see, you might be pretty surprised. You might be pretty surprised because you never had thought in your mind that all this kind of a processing was going on in your mind. But actually, all this thing had happened. Actually, all this had happened inside your mind. Right? So that was the one which probably was those are the cases which matched the maximum. One and one. Right? So in my case, the one on this one, I give it a higher rating. Why? Because again, the inside part, if you see the inside of the petal, right, the center part, there not only the pattern but the color also matches. Right, that's why it got a higher voting in my case. But yeah, otherwise, more or less same. Right. So let's come back. We need for classification. One is we need features that can be quantified. So model data with features that can be quantified. Right. So, for example, you might ask the professor, how can we quantify colors? So, in fact, colors also can be quantified. Color can be all the colors. They are a combination of R, G, P, red and blue. All the colors are a combination of that RGB. Right. One is a feature that can be quantified. Second is labels that are known. Right. I know some of the labels, right, in terms of probably this is round, this is oval, so some kind of labels like that. And then some kind of a methods to measure similarity. How do I measure the similarity? You are saying that this color is very close to this color. What goes on inside? Right. Coming back to the colors, so I talked about the RGB. So every value of this RGB, and it can take a value of 0 to 255, 0 to 255, 0 to 255. Right. These are the numbers are nothing but the intensity. If I take RGB all as 0, the color will be white. If I take 255, 255, 255, it will end up a black color. Right? By just varying the intensity of the colors, I can probably do different combinations of the different colors. So coming back to classification techniques, you have base classifier and you also have ensemble classifier. Right? So base classifier, right? So we are going to talk about the base classifier. So ensemble classifier will only come in your term 2. So these are some of the base classifier: decision tree, nearest neighbor, neural network, naive Bayes, support vector, right? These are some of the base classifiers. While you also have ensemble classifiers, boosting, bagging, random forest. We'll talk about all these things. Right? So base classifier means a single kind of algorithm only. A single kind of algorithm is being used. Right? So if I look at the different possible learning methods, you have eagle learner and you also have instance-based learner. Right? So eagle learner, what does it does is that it basically matches, right, the data on the whole of trained data. Eagerly it is trying to learn. And instance-based learning is basically, it looks into case-by-case examples of looking into this. So let's talk about the first algorithm which we are going to learn, which is basically the K nearest neighbor, also talked as KNN. Right? KNN, it's an example of an instance-based classification. I'll show you why it's called instance-based classification. Right? Remember one of the examples of instance-based classification we took up in the last class, right? Where we were talking about this example of platypus, how it got its name. That was nothing but an example of an instance-based classification. So here, all the instances corresponds to point in the n-dimensional space. And here, a new classification is delayed until arrival of a new instance. Right? Let me show you an example. Okay. Let's look into the data. So the data is having two classes. One is this minuses, the other is this pluses. Right? Again, let me probably put you through an example. Let's say, and I don't remember whether I've shared this example with you or not. Let's say that, okay, I mean, you're meeting some of your friends after 5 years, right? And then you ask them that, okay, what are you doing, right? So one guy says that right now he is living in Beverly Hills, or let's say in Manhattan. What will be your first reaction? This person is living in Beverly Hills or Manhattan. What will be your first reaction to this? The person is living in Beverly Hills or Manhattan. What will be your first reaction to this? Subramania is saying surprise. Okay. Anything else? Your friend is living. I mean, why you should be surprised, right? Happy, right? Yeah. Anyone else? What should be your first reaction? What will be your first reaction? Your friend is living in Beverly Hills or sleep. What will be your first reaction to that? First reaction to that. First reaction to that. First reaction to that. Would you think that probably your friend is doing pretty well? That he has probably ended up in Beverly Hills? So something that you come to your mind? Vis-a-vis, let's say your friend is living in Dharavi. Dharavi, I think you know, it's the largest slum in Asia, right? It's in Mumbai, right? So your reaction is, if you hear that your friend is living in Dharavi, your reaction is, poor guy, right? Couldn't do much in life, right? So now your friend living in Beverly Hills doesn't automatically means that he's doing very well. He probably is doing some kind of a menial job in Beverly Hills. You never know. Maybe he's just working in some particular store as a cashier or something like that. Whereas your friend is living in Dharavi, probably has probably made a palace out there. You don't know. But what you have done is in your mind, the first characteristics of that particular area, you have attributed that to this whole piece, right? Dharavi, the first thing which comes in your mind with Dharavi is slum. That is probably the characteristics that you have attributed on your friend, which might not be true, by the way. Which might not be true, but that's what you have done, right? So that brings us to K nearest neighbor or KNN, right? This particular point, if you see this unknown point which is marked with X, this unknown point marked with X, right? If I see this particular point, if I take the one closest neighbor, the neighbor is marked with a minus. Probably I'll say that this particular point is a minus. That's the level of this particular point. Now, rather than one neighbor, I probably increase the reach. I take two neighbors. So now one neighbor is saying positive, the other neighbor is saying negative. So I'm probably a bit confused with this particular scenario. That what should be the level of this one. So I increase the number of neighbors more, right? I take the more, increase the radius more. Now I have three neighbors, of which two neighbors are saying positive and one neighbor is saying negative. I'll take the majority. The majority is saying plus. So this unknown point, I'll mark it as plus. That is basically the essence of this K nearest neighbor or KNN. Right? So this is the KNN part, right? So quickly, let me do this KNN classification. We'll just get it started, but again, we'll continue in the next session. So I'm here, I'm presenting you a case. So let's say that unfortunately, you have to take a friend to a large hospital, and this hospital is very famous or efficient for treating, let's say, cancer patients. And the two most important attributes of the patient that they look into before even giving you a admission or probably some kind of appointment: the age of the patient and the number of malignant nodes that the patient is having based on the last scan, right? The age of the patient and the number of malignant nodes, right? These are the features which are there. And by the way, on the left-hand side of the diagram, you see that there are two labels which are there. One label is survived, the other label is did not survive. Survived and did not survive. These are the two labels which are there, right? Okay. Survived, did not survive. So now, one day, right, as I said, that you have probably got a friend, right, who probably unfortunately has been diagnosed a malignancy. You take your friend to this hospital. The first question the doctor asks is that, okay, right, what's the age of the patient and what is the number of malignant nodes that this patient is having, right? So this is your patient. Now, as you see, this patient is having age somewhere around 21, and the number of malignant nodes is about 11 or 12, right? Now, once you have mapped this particular patient with respect to the age and the number of malignant nodes, right? The doctor has taken the note. You eagerly ask the doctor, so doctor, what do you think are the chances of my friend? Doctor, good doctor, right? He says that, okay, let me take a look into similar cases. And what the doctor does is that he looks into the most similar case of this particular patient. Doctor says, sorry, my dear friend, based on a case which we have recently handled for someone who had maybe one or two malignant nodes more, maybe about 12 malignant nodes, and the age was also the same, almost same. Your friend is 21, this guy was 20. Unfortunately, this person did not survive. So obviously you are very unhappy, your heart sank. But then you ask the doctor, can you look into some more cases? Doctor is very good. He said that, yeah, let me look into some other similar cases. And here is the next best case which the doctor finds out. Here is another patient which had 10 malignant nodes. The age was probably a little lesser, about 16. And this patient, by the way, survived. So now you are two decisions. One case is survived, one is did not survive. So you eagerly ask the doctor, I mean, now though we don't have a very clear-cut decision, can you look into some other decision, other patient? Doctor is good. He said, okay, fine, let me look into some other patient. And here is the third closest patient, right? This patient is having about 9 malignant nodes. Age is a little bit more, about 25 probably. And this patient also survived. So now you have 3 cases, of which 2 cases survived, 1 did not survive. So 2 of those 3 cases support surviving. 1 of those 3 cases support did not survive. But now you have become more hopeful. Doctor has also become more hopeful. Ask the doctor that, okay, doctor, can you look? Doctor himself volunteers, and here is the 4th case. The fourth case also, what you find is that the patient had survived. So right now you have 4 cases, of which 3 survived, 1 did not survive. We will go in for the majority, and the verdict is that this patient probably will survive. That basically is the inspiration for this KNN model, K nearest neighbor classification. Right? So this whole thing, which are depicted, that will basically lay the foundation for your K. Right? So here there are 2 fundamental questions that you might be probably thinking of. One question is that, okay, professor, you said first to start off with K equal to 1, then you took 2, then you take 2, 3, then now you're saying 4. Then what is the correct value of K? I think that's one of the question. And then the other thing which I was doing, I was saying that, okay, this is 1 closest neighbor, 2 closest neighbor. How in the first place you are finding out the closeness of the neighbor? That's probably the other question which is there. So these questions, let's get started, right? So as I said that I can take probably one neighbor, I can take many different neighbors, right? So here, neighbors, whenever I'm saying neighbor, so it is in terms of less distances. So these are all people, they are my neighbors, right? But probably this and this, they are not the neighbor. The distance is very high, right? So let's say I take only one neighbor, right? Whatever my one neighbor says, I'll go by that. If you take one neighbor, you see, this is what happens. Your decision becomes very localized. So see, in this particular zone of blues and reds, this particular part, this particular point has marked a region around as red. This particular point has marked a region around it as blue. Right? So if you have very small number of neighbors, decision it tends. Then if you have two large number of neighbors, it gets generalized. So here I've taken a large number of neighbors, and what has happened is that I've not created a model as such. You can see out here, no model has been created as such. We have just taken the majority of the points, right? And that becomes the decision, right? So the point which is in majority here, blue was in majority, so that became my final decision. So a very high value of K as well as a very low value of K, both are probably suboptimal. What we need to do is that we need to probably have an optimal value of K, right? So show you K equal to 1 and K equal to all. Both of these are bad, right? And how you're taking K, that actually affects how the decision boundary will get created by you. So we talk about methods to determine K. The first thing is, how do we measure the distance, right? Here is this particular point, unknown point, which I'm going to measure. And let's say I take this particular point for measurement, these 2 points. How do we measure the distance? How do we measure the closeness, right? So let me take you back to your school days, maybe class 7 or 8. Pythagoras theorem, Euclidean distance. What? Euclidean distance, right? So if I do this and this, right? This is number of nodes and this age. So this particular part this diagonal as per Pythagoras theorem, that is equal to ag square plus node square. So d is basically root over of ag square plus node square. My bad, sorry. Right? So that comes from the Euclidean distance or the L2 distance. Right? This is the Euclidean distance for measuring the distance. There's also another distance, which is the L1 distance or the Manhattan distance. L1 or the Manhattan distance. What does it say? L1 or the Manhattan distance or L1 or the city block distance. In the Manhattan distance, what we do is that we take the absolute distances. This absolute distance plus this absolute distance. We add up these values. So by the way, absolute distance, why I'm saying is, we just need the dimension of this particular values, right? This value plus that particular value, right? Unlike the previous, where we are taking the shortest distance between these 2 points based on this Pythagoras theorem, this one probably doesn't take the shortest distance, but again, it takes probably basically the absolute distance across all these quadrants. That is the Manhattan distance or the L1 or the city block distance. So these are the different measurements: Euclidean, Manhattan, and Minkowski. So Euclidean here, in the case of a Euclidean, this is the Euclidean case, this is the Manhattan case, this is the Minkowski. Euclidean is the L2 distance, Manhattan L1 distance, and Minkowski it's a generalized distance value. Right? Minkowski is basically write as Lk. If you put the value of k as 1, you can see in the formula, it becomes a Manhattan distance. If you put the value of k as 2, then it becomes the Euclidean distance. K1 Manhattan distance, K2 Euclidean distance. So these are probably the numerical measurements. For numerical variables, you use Euclidean or Manhattan distance. For categorical variables, by the way, categorical variables, categories are there. So there you use basically something called as this Hamming distance. Hamming distance. Now, what is this Hamming distance? So if the values they're the same, then the distance becomes 0. If the values they're different, then the distance becomes 1. So here you see that this 2 values are there. In the first case, this one is male, this one is also male. The categories are same, so they are same, no difference between them. Distance is 0 as per Hamming distance. In the second case, you have a male out here and a female out here, right? This and this, they are not the same. So this 1, right? So 1 is this particular part is for your numerical. This particular one is for categorical, right? So let me show you this particular example. So here you have this patient, 3 patients, patient A, patient B, and patient C. They are there. And here the ages of the patient, right? So based on the age of the patient, is A closer to B or A closer to C? Switch into the class. Taking the age into consideration, is A closer to B or is A closer to C? Is A closer to B or A is closer to C? What is your take on this? Subramania is saying that A is closer to B, right? Anyone else would like to counter that? Aniket, Sachin, would you like to counter that? Would you like to counter that? Yeah, Aniket. Yeah, Aniket. A and B are same. Not really. Not really. So I've asked you to look into just into the age part. If you look into the age part, A and B, they're different. If you see the age of A, that is 50, while B is 20. So the distance between A and B is 30. Whereas if you see A and C, A is 50, C is 50. Same age, no distance. So in terms of the age, A and C are close. While if you look into the part, which is the gender. So gender, we have this both as this males, right? Both the genders, A and B, they are male, while A and C are C is female. So now based on the gender, is A close to B or A close to C? A is close to B or A is close to C? In this case, A is close to B because the genders are the same. Both are males. While, so the distance between A and B this time is 0. Both are male, having distance. While the distance between A and C, it is 1. Because A and B, C, they are different. So now the next challenge is probably, how do we combine both this information to come to a representation of the distances? So what I'll do is I'll probably stop here today. And this particular part will continue fresh minds in the next session. But before I log off for the day, you have any questions? Any particular questions? Any particular questions that you're having? Yeah, Aniket, what's the question? Yeah, Aniket, I'll do one thing. I'll unmute you. Yeah, Aniket, tell me.
Yes. During standardization, as like we told, 4 cylinder and number of CC, like that, if we have a one variable that we don't know much, how do we process up?
Sorry, I'm not getting a question. There's some lag or some breakage, right? If you can rephrase your question again, if you can just say.
During the normalization process, right?
Yes.
In that, how do we came to know if it is a categorical data and numerical data? If categorical data are represented as numbers.
See, categorical data, I mean, that will come as part of your pre-processing. So if you have categorical data or categories, right, you're only going to convert that into cases. Say, for example, here you have gender, male and female. You could have converted that to 2 categories, gender male and gender female, right? Like we have discussed in today's class.
Right? Yeah. So, for example, we consider example of a flowers.
Right.
If we have one variable which is unknown, like number of petals, take examples, the number of what you call petals in the flower, like number of 3, 4, like that.
Okay.
But, we don't label that.
If you don't label that, you'll not take it as a feature. It will remain as an attribute, but not as a feature. Features are the one which probably will help you in the modeling process.
Okay.
Features are the one which will probably help you in the modeling process.
Okay.
I think maybe you are probably not asking the right question, right? I'm not able to follow the question. Right? In any case, what we'll do is we'll probably take up this particular part only in tomorrow's session, right? This is probably where we'll get started, and you can probably make yourself more clear with respect to the question part. I think you have some doubt, but again, I'm not getting exactly that what exactly is the query, right? Give it a thought, come back tomorrow, and we'll probably discuss.
Okay.
Fair enough, Aniket?
Yeah.
Yeah. Any other one? Any other questions? Sachin and Subramania? Sachin, Subramania, any other questions?
Nothing from
No?
my side, sir. Yeah.
Okay, I understand. I'm also coming between you and your dinner probably. So fair enough. So yeah, we'll stop here. We'll stop here today, right? And yeah, what we will do is we'll probably in the next session, we'll take up this particular part, solve, we'll discuss how you can solve questions like this. And yeah, please ask more friends to join, right? More and more friends to join, right? Because we discuss interesting stuffs in this, right? So with that, probably I'll bid you good night for the day, right? Yeah, just one thing is that, as I said, that next week, next Sunday, I think it's, it's probably in the middle of this Navratri, which will happen. If possible, right, just check with your friends that if we can have the session rather than in the evening, if we can have it in the morning, right? If I get an indication from your side, right, you can probably write to your grad folks so that they might reach to the class to the morning part. Maybe morning 10:30 to 1, we can have the session, right? But again, that will go as per your convenience, right? Otherwise, it stays at 7 to 9:30 slot for next week. Fine. So thank you, everyone. Right. So I'll meet you again tomorrow morning at 10:30 sharp. Right. Till then, have a nice night. Right. Enjoy. Right. Meet again tomorrow. Thank you, everyone. Good night.